Assalamu alaikum warahmatullahi wabarakatuh. Good morning, everybody. Today, our lesson is classifying triangles. In this lesson, we will classify triangles by their angle measures and side lengths. Also, we will use triangle classification to find angle measures and side lengths. We have some vocabulary like acute triangle, equiangular triangle, right triangle, obtuse triangle, equilateral triangle, isosceles triangle, scalene triangle. Now we have a triangle with three sides, AB, BC, and AC, or the sides of the triangle ABC. Also, the vertices of this triangle A and B and C. The triangle classification, let's start with angle measures, okay? We know that we have acute triangle from acute angle. This triangle has three acute angles, like this triangle. If you look here, you will find the first angle is acute, the second angle also is acute, the third angle is acute. And we know that the acute angle is an angle its measure is greater than 0 and less than 90. The second type is equiangular triangle. And the word or this part equi come from equality. So equiangular triangle, which a triangle has three congruent acute angles. So in a triangle has three congruent acute angles will be equiangular triangle. Like this, if you find that the three angles are the same measure, so this triangle is called equiangular. The third type is right triangle. This right triangle has exactly one right angle, and we know that the right angle like letter L, like this. So the right triangle is a triangle has one right angle and the other two are acute. The fourth type, obtuse triangle, which has one obtuse angle, like this. You can see now this angle is obtuse and the other two angles are acute. And we know that the obtuse angle is an angle, its measure greater than 90 and less than 180. Now, let's see the first example. Classify the triangle BDC by its angle measures. Who can tell me how many triangles in this figure? Yes, we have three triangles in one figure. The first triangle ABD, the small triangle, the second triangle BDC, and the third triangle ADC. So please read the question well. We talk about the triangle BDC. Look, B, D, and C. So in this triangle BDC, we have angle C, which is 10 degree, and angle B, which is 100 degrees, like this. So we can find now one angle of the angles of the triangle is obtuse. So this triangle will be an obtuse angle or obtuse triangle, like this. Angle B is an obtuse angle. So the triangle BDC is an obtuse triangle. Let's see another one. What about triangle ABD, the small triangle? We know the first angle, which is ADB, or you can say angle D, because we talk about the small triangle. Its measure is 20 degree. And angle A, which is 80 degree, I cannot say that I can determine the type of the triangle now, because there is a third angle, which is B. I cannot calculate its measure until now. So before you answer the question, please calculate the measure of the angle B in the small triangle ABD. Yes, excellent. We have here the two angles ABD, which is this angle, and the angle CBD are a linear pair or form a linear pair. So they are supplementary. Supplementary, it means the sum of their measures equals 180. And because we know that angle or measure of angle CBD is 100, so its linear pair will be 180 minus 100, which is equals 80. So in the small triangle ABD, we have angle A, which is 80, and angle ABD, which is also 80, and angle ADB or angle D equals 20. Now we have three acute angles in a triangle. So the type of this triangle, according to its angle measures, it will be, yes, acute triangle. Now we have check it out. Please read the question well and solve it alone. Stop the video now and then open it again and check your answer. Now let's check the answer. Classify the triangle FHG. FHG. FHG means this triangle which is on the right. FHG. In this triangle, we have two angles. The first angle, G, its measure is 60. And the second angle, which is HFG, or angle F on the small triangle, 60 degree. So what is the measure of the third angle? So we know that all angle EHG is 90. This is the notation of 90. So this part, the left part, is 30 degree. So the right part is 90 minus 30, it will be 60. So we have in the triangle HGF or FHG, we have three angles are acute and congruent. So what is the type of this triangle? Yes, the type of this triangle is equiangular triangle by the definition, because we have three angles and all are acute and all are congruent. Let's see. The second classification of the triangle we have by side lengths. We have the first one, which is equilateral triangle, equilateral triangle, or equilateral triangle. In this triangle, the three sides are congruent. The three sides are congruent. It means the three sides have the same length. Okay, let's see. It will be like this. And you will see in the equilateral triangle that you have the same sign on the three sides. The second type is isosceles or isosceles triangle. This triangle has at least two congruent sides. It means maybe a triangle has two sides are congruent like this, so it will be isosceles triangle, okay? The third type is scalene triangle. The scalene triangle is a triangle with no congruent sides. It means the three sides are different in length. Look, the first side is very small and the second side is between, and the third side is the longest side. So there is no congruent sides. So this scalene triangle. Now, when you look at any figure, you cannot assume segments are congruent based on appearance. Don't say, Mister, I feel that they are congruent, or Mister, they seem to be congruent. No, they must be marked as congruent. So here in this question, classify the triangle EHF by its side lengths. Okay, the first triangle EHF, look, EHF. In this triangle, we have two sides have the same sign, FH and FE. They have the same sign, so they are congruent, okay? And the third side doesn't have the same sign of them. So what is the type of this triangle? Yes, it's isosceles. So the triangle EHF is isosceles triangle. Now the triangle EHG, EHG. Look, we have the first side HG, its length is 11. The second side HE, its length is 12. And the third side EG, its length is 14. So what is the type of this triangle? We have now three different sides. There is no congruent sides. So the type of this triangle is scalene. Now check it out, solve and stop the video, then check your answer. Now let's check the answer. Triangle ACD. I know that most of you solve it as it's isosceles because you depend on that AB is congruent to AC because they have the same sign. But what about we have AB is 15 unit and BC also is 15. So this triangle is the triangle ABC is what? the triangle ABC is equilateral triangle, and the triangle ACD has three different sides, 18 and the 5, and this side AC is also 15. So the triangle ACD is scaling. So let's see example 3 using triangle classification. Here we want to find the side lengths of the triangle JKL. JKL. This triangle, we have three sides, okay? The first side, JK, is congruent to the second side, KL. They have the same sign here, so they are congruent. Now, we write that the given JK and the KL are congruent. Then, we can substitute. We know that the length of JK is 4x minus 10.7, and the length of KL is 2x plus 6.3. It will be, you know, that the definition of the congruent segments, that the length of each side is the same. Then substitute, you will see equation from algebra. We can solve it. We have add 10.7 to both sides and also subtract 2x from both sides. So we will find that 2x is equal to 17.0 or 17. Now divide both sides by 2. So x equals 8.5. We finished now? No, we want to find the side lengths of the triangle. So we will substitute by x equals 8.5 in the three sides. Okay, so the side JK for x minus 10.5, substitute by 8.5 for x. So 4 times 8.5 minus 10.7, it will be 23.3. And also KL, yes, you can find it directly. It will be the same length as JK. But check your answer also. It will be 2 times 8.5 plus 6.3, which is also 23.3. And the third side, which is JL, equals 5x plus 2, 5 times 8.5 plus 2, calculated, it will be 44.5. Now we have checked out. Solve it alone, stop the video, then come back to check your answer. It's given that the three sides of this triangle are congruent. So the type of this triangle is equilateral. It's written here, it's equilateral triangle. So the three sides are congruent. So the lengths of the three sides are equal. So substitute, you can write now any two of them. Any two of them. Don't use the three. Only any two of them will solve this question. Now we have equation. 3y here and 2y here, so we can subtract 2y from both. And negative 4 here, positive 3 here, so we can add 4 to both sides. So we have y equals 7. Now substitute in one of them first, 3y minus 4. So 3 by 7 minus 4, it will be 17. Now, to check your answer, you can substitute also. It will be 2 by 7 plus 3 and also 5 by 7 minus 18. Now you can see that the three sides are equal in length. Example 4, application. We have a steel mill produces roof supports by welding pieces of steel, beams into equilateral triangle. We have now equilateral triangles. Each side of the triangle is 18 feet. So we have equilateral triangle. Each side of the triangle is 18 feet long. How many triangles can be formed from 420 feet of steel beam? So in this question, the amount of steel needed to make only one triangle is equal to, yes, the sum of the three sides of the triangle, means the perimeter P of the equilateral triangle. So who can calculate with me the perimeter of one triangle? We know that the equilateral triangle, the three sides are equal in length, so the perimeter will be 18 plus 18 plus 18, or 18 times 3, which is 54 feet only to form one equilateral triangle. What is the amount of steel we have? 420. So to know the numbers of triangles, or the number of triangles can be formed, so we will divide the total amount 420K by the amount of steel needed for one triangle. So it will be 420 divided 54, which is 7 and 7/9 triangles. There is not enough steel to complete the 8th triangle. So the steel mill can make only 7 triangles, okay, from a 420 feet. I cannot say that the number of triangles 7 and 7/9, and I will not approximate it. So we can form only 7 triangles. Now solve, check it out, and let's check the answer. Don't forget to stop the video. Yes, welcome back. The amount of steel needed to make one triangle, we said calculate the perimeter of the equilateral triangle, which is 3 by 7 equals 21 inch. Then divide 100 by 21, or 100 by, divide 100 by 7 first, it will be 14 and 2/7. So I cannot write like this, so I can answer as only 14 triangles for a 100 inch. Okay, check it out. 4B. Let's see. The amount of steel needed to make one triangle is equal to the perimeter B of the equilateral triangle. So P equals 3 by 10, which is 30. Then to find the number of triangles that can be made from 100 inches of steel, divide this 100 by the amount of steel needed for one triangle. So 100 divided 10 equals 10 triangles exactly. So the answer is 10 triangles. We have now lesson quiz. You can solve it, and please send me your answer and I will check it. Bye bye.